Good evening, welcome to episode 3 on the design philosophy. You'll notice I brought a prop. We'll be needing that later. Now, in the last episode I said that Britain had entered World War II with no heavy or particularly special tanks at all, and I think it's important that going forwards here we stop to quickly look at how that point was reached and what the British did have in 1939. Britain had been the first nation to develop tracked armoured vehicles in World War I, and following the war the army and its fleet were massively reduced. Indeed, tanks were almost an afterthought for many planners and politicians alike, as if they were only to be used in the war they just had, and maybe would not be needed going forwards. In the aftermath of post-World War I cutbacks, the army was reduced from 25 tank battalions to just 4 by 1923. Post-war, Britain also needed to reassert control over its empire, and a clue to the importance, or lack of it, of tanks quickly came in the form of the events in British Somaliland. I wrote about this policing action for Tanks Encyclopedia. There'll be a link in the description below. And that action is notable for its complete lack of tanks. The force dispatched there deliberately chose not to seek armoured support at all, and was, instead, mostly dependent upon air power ahead of its ground forces. When they did meet defences, it was often simply heroic infantry actions which broke the deadlock, somewhere where tanks would have been a far simpler and frankly safer solution. The target of the whole affair, Mullah Hassan, fled rather than use his huge defensive fort system in the south. Had he done so, then the light British forces, even with air power, would have struggled. Whereas, of course, if they'd brought tanks with them, they would not. If anyone, therefore, in the military in Great Britain in the early 1920s was advocating for tanks for colonial policing duties, then this singular action could easily be used to underscore just one example of why tanks had seen their day and the future lay in air power. Most of the British efforts of this interwar period, then, were a mess, with different schools of thought trying to envisage if there was any need for armour, and if there was, what sort of vehicles they would actually want. Indeed, many in the army even still thought that the horse had some kind of role in the future, although the War Office, in a moment of clarity, was just as equally keen to get rid of its horses completely as it was to become fully mechanised. A flavour of this confused thinking comes from Lieutenant Colonel Percy Hobart. He came to the Tank Corps in 1923, wanting a shift to light fast tanks and mobile artillery. Colonel Fuller and Little Hart wanted a completely independent tank force, focusing on light, fast and mobile vehicles. In The British Way of Warfare in 1933, Little Hart even argued for a maritime-led strategy supported by air power rather than large land forces. When it came to tanks, he was generally enthusiastic for light ones. Someone like Major Martel, on the other hand, wanted tanks as an adjunct only to infantry units. An experimental mechanised force was formed in 1927 to look into some of these issues, but met with serious resistance from some in the army, and was renamed the Armoured Force in 1929. By 1931, a new tank brigade of medium and light tanks was created, but it is worth noting that General George Mill, Chief of the Imperial General Staff and organiser of the experimental mechanised force, said in 1929, quote, "What we are aiming at is the proper organisation of 4 basic formations, the Cavalry Brigade, the Light Armoured Brigade, the Medium Armoured Brigade, and the Infantry Brigade." In 1929, Colonel Broad at the War Office put out a thing called the Purple Primer, which once more advocated for mechanised forces, but specifically just in 2 parts, reconnaissance and striking. Milne, for his efforts, had been trying to create an all-arms force, rather than Martel's infantry-dominated force, and yet it is perhaps because of this reshaping of the armed forces that it took until 1933 before a permanent armoured brigade was finally established, some 15 years after the end of World War I. And what there was 2 simple basic schools of thought. A light, fast, mobile school, where tanks were the new cavalry for scouting and exploitation, and an infantry support school. Whereas the former would emphasise speed and shock action over firepower and armour, the latter would emphasise protection so that they could support the infantry and destroy enemy positions. Neither plan was focusing on tackling enemy armour specifically, or for dealing with heavy defences. The closest in this regard perhaps to an unfilled need was a training pamphlet issued in September 1939. The same month war was declared. British Army Training Pamphlet number 22, Part 3, Tactical Handling of Army Tank Battalions - Employment. Quote, Army tank units are equipped with tanks possessing heavy armor, relatively low speed, and high obstacle crossing power. They have no weapons for their own close support other than smoke projectors, nor have they any special reconnaissance sections. Thus, they are not designed to act independently, but in cooperation with infantry and artillery. By virtue of its high degree of firepower, mobility, and protection, the infantry tank is preeminently an offensive weapon of great effect in battle. So there, on the eve of war, Britain had infantry support tanks and a reconnaissance force. It would pay the price in 1940 of the dithering of the 1930s. The confusion and arguments over what tanks and what type of tanks the British Army needed had led to three basic types being employed by this time. Light tanks for reconnaissance, like the Vickers Light Mark VI. Infantry tanks for supporting a primarily infantry-led assault, like the A.12 Matilda. And fast, light, armoured cruiser tanks, with an emphasis on exploiting breakthroughs. The irony, if indeed that's the right word here, was that light tanks were basically so light as to be almost useless, infantry tanks would end up doing all of the fighting, and that the exploitation tanks would be the ones better suited to the reconnaissance instead of universal type carriers. If the new war, and war was definitely on the cards in 1939, if that new war was to follow even roughly the same lines of World War I, with some well-defended positions, then the lights and cruisers had not got the armour to lead an assault, and the infantry tank A-11 lacked the firepower to tackle well-defended positions. The brand new infantry tank, the A-12 Matilda with a 2-pounder gun, was a substantial improvement, but was also limited in its own design. It was complex to build, and it carried a 2-pounder gun. It lacked the heavy, high-explosive delivery gun that it needed. By the outbreak of war in 1939 then, there was simply no heavy tanks. There were, however, those well-protected infantry tanks that I've already mentioned, so let's quickly review those. The A-11, the original Matilda, infantry tank Mark I. Heavily armoured with 60mm of protection and a single machine gun, either a .303 or .5 caliber Vickers, the armament wasn't perhaps as weak as might be surmised. The British .303 armour-piercing round could perforate up to 25mm of mild steel and around 12mm armour plate at 100 yards. The .5 caliber Vickers firing armour-piercing ammunition could do a little more, and given that the goal wasn't even tackling enemy armour but was tackling enemy troops and positions, that was pretty reasonable. A .303 AP round could breach a concrete slab up to 4 inches thick, especially if it was concentrated in a small area. Again, the .5 caliber Vickers a little more. Given the light armour used by Germany at the time, then even that weapon was still a credible threat to enemy armour, and a small reinforced infantry position, albeit not a heavily reinforced position. The vehicle would carry relatively little ammunition, however, just 3,000 rounds for the .303 and 1,200 for the .5. The A-12 was still a relatively new tank in service in 1939. With 3 inches of armour, the A-12 was even better protected than the A-11, and better armed with a machine gun and a 2-pounder gun. The 2-pounder gun was certainly more than sufficient for knocking holes in any enemy tanks of the period. It was also fairly good at poking holes in concrete as well. A 2-pounder armour-piercing round at 2,300 feet per second, 12 shots, and an impact area about 10 times the caliber. So the caliber is 40mm, 10 shots into an area of about 400mm could pierce 3 feet of reinforced concrete. And at an improved muzzle velocity of 2,850 feet per second, just over 4 feet. For reference, if you need it, the 6-pounder armour-piercing round at 2,500 feet per second could do about 5 feet, and it wasn't actually until the arrival of the 17-pounder armour-piercing ammunition at 2,500 feet per second that over 7 foot of reinforced concrete could be pierced. This will become very relevant when you have a look at RBM 17. Again, I'll come to that in a little bit. In terms of trench crossing, there was an issue too. The original plan for the A-11, as shown on Sir John Carden's sketch in October 1935, showed a machine crossing an 8-foot wide trench, but by the time the vehicle was in production, the actual trench crossing ability was just 6'6". So what the British had in 1939 in the form of the A11 and A12 were a pair of reasonably well armoured, certainly good enough to protect from the German 37mm gun, tanks, but whose firepower lacked the potential for growth and for properly tackling hardened enemy bunkers. Further, the 8-foot trench might be crossable just by the new A12 with a tail, but it was certainly not crossable by the A11. Further, that was just a trench. That did not mean it could deal with the most basic defence against tanks, the anti-tank trench, or anti-tank ditch. So in July 1939, that's what there was. All of this difficulty in crossing broken ground and obstacles was already known to Stern, and even before the official specifications for what was going to be wanted were issued, it was clearly obvious what gap the British Army had. They lacked a bigger and heavier infantry-type tank which could do all of the infantry support work for an attack and also cross obstacles. Those ideas were made clear in September when the first concept of what Stern and the others were thinking was shown, and that was 300G. Now, I wrote about 300G for Tanks Encyclopedia as well. Once more, the link will be in the comments below. And once more, there is a thing to cover before we go further. All of the drawings from William and Foster & Co. were numbered in the XXXG format. It is not possible to date 300G from those dates, but from the letters about the design. For confusion on the topic, the same outline are also listed as TOG 2 1941 in one archive, which, as we will see as we go forward, cannot be correct due to the huge changes in layout, turret and armament which had been put in place by 1941. That is how 300G is dated to September, as long as mentions of that in the record. Nonetheless, I wanted to mention that because at some point another copy, 3 copies of every set of plans are known to have been made. Another copy of those plans might turn up somewhere else with a different date or name, possibly adduced to show a different feature of the design, and I would like to make sure we're talking about the same thing. The 300G then, for lack of a better name, was drawn in 2 forms. A short bodied form with a top track running level with the roof and a sharply angled rear deck. In this shape, 300G is remarkably similar in profile to an actual A.12 Matilda, albeit with a slightly steeper glacis and a raised track run. The second outline shows the same front shape with an angled glacis plate, vertical driver's plane, a track return below the roof level of the hull, and a sloping rear engine deck. This version was significantly longer, and both were shown topped with an A12 style turret. Another common feature across both outlines was to live on long after these were abandoned, and that is the high and well forward front idler. We will come back to that important feature in just a minute. Of the tank, it would measure between 20 and 25 feet, 6.1 to 7.6 meters long, for the compact and lengthened options respectively. The width is easy to gauge as it is shown in a railway tunnel. Railway tunnels were the size limiter for width, and the 300G vehicle is completely filling the tunnel in the drawing, indicating a vehicle of some 10 feet, just over 3 meters wide. Quite exactly what this vehicle was supposed to offer over an A12 is not entirely clear. Certainly there would be room in this bigger vehicle for a front hull mounted gun, like a machine gun, perhaps on the sides as well to help with that suppressing the enemy work. Given that the use of the A12 style turret too, the armour was probably not going to be considerably more than 3 inches thick on the front, down to maybe as little as an inch on the back. Even if this vehicle had offered a small improvement in firepower over the A12, its biggest advantage was going to be that it could cross an 8-foot gap instead of the standard 6'6" gap. And this was simply advantage, but simply not enough of an advantage to outweigh the A12, which as I said before, could already mount a trench crossing tail anyway. The A12 was also a difficult vehicle to make, and that cast turret, shared on 300G, was going to be no simpler. So really, the 300G is as much a thought exercise from Stern and the others. When the formal specifications were issued at the end of September 1939, the 300G idea was dead. But I need you to remember a couple of key points. A slightly longer vehicle for crossing obstacles, good protection, and a turret. Now, here I want you to stop quickly and address a couple of questions from previous episodes on this topic. The first question is from Ed Francis. He asks, at what point did the old gang realise that the war was not going to be one of stalemate and mud, and did they ever start to doubt their work, as it was clear by mid-war that the tank design was going in a different direction? Well, what I would say is that the vehicle I've just been discussing, 300G, really shows that right from the outset, men like Stern and the others were considering that some elements of World War I might be repeated, such as the heavily defended positions. But really this was nothing unusual, and numerous times during World War II on different fronts for different forces, heavily fortified lines had to be breached. So maybe it's a misnomer to focus quite so much on the World War I elements of stalemate, and instead more on the breaching of heavily defended positions instead. The high front track end, I promise I will get to why that's important shortly, the need for improved protection even over the good protection of the A12, and the need to cross wider obstacles all being part of that. I'd ask people to note the irony of this 300G infantry tank type design as not actually being that far removed from the Mark IV infantry tank actually turned out eventually in the form of the A22 Churchill. That simply reinforces to me that these men were thinking along the correct lines prior to RBM 17, which, as we shall see, was substantially going to complicate their ideas. The second question is from Noldo, asking how this helped mobile warfare, specifically doctrine. How is this helping a mobile war? There is no successful tank of this kind anywhere. Well, what I would say is that pre-war the British were clearly keen on a very mobile type of warfare, as I covered earlier, and simply lacked a vehicle which might prevent a completely immobile type of warfare, and that this vehicle was not the tank to be for all seasons, the tank for all purposes and all places, but a vehicle for a special role. This was repeated elsewhere in Europe at the time with ideas of breakthrough tanks of one type or another. I would leave it to other people to debate the merits, successes, failures or otherwise of all of those other nations' breakthrough tanks. Final question for the day is Morgan Barry, who asks, was the TOG really initially designed with the World War I concept that the vehicle would need to traverse over trenches and ditches? If so, what were the amendments made to the design in early World War II or prior to the design being mothballed? So that's a really good question, and the answer is yes and no. As I've tried to show so far, there was generally an accepted idea that 8 foot or so of trenching was going to need to be crossed at some point. And from a mobility point of view, the more your tank can cross without special bridging equipment or fascines, the better. Now, the army was going to want more than that for a special vehicle, but that would not be known to Stern and the others until the end of the year, at which point, as will become clear, some in the army definitely thought World War I type battlefields were on the cards. Okay, so just as we hit on there before, we were talking about trenches. So we can't just say trench, because like everything else, the crossing of a trench, ditch, or other obstacle is no small problem for any tank. Even prior to the formal specifications being issued, we see a slightly longer and heavier tank than A12 being considered. That's the 300G. And in fairness, if we allow that 6'6" crossing A12 the credit of meeting the demand for an 8 foot using a trench tail, then we should do the same for 300G too, which might have meant 10 foot of trench crossing. That is a bit of a digression. Certainly, however, a trench tail was not something abandoned at all, and would even be postulated later for the TOG work, and for that matter for the A20 as well. So crossing obstacles was definitely something which exercised a lot of thought at the War Office. Truth be told, in 1939 they simply didn't have a good vehicle which could do it, and that's where the TOG comes in. The long and short of crossing a gap is that the bigger the gap, the longer the vehicle. Longer helps in crossing the obstacles. So the gap shown on 300G was 8 foot. It can be no coincidence that the A11, A12 and 300G are all thinking 8 feet. The 8 foot recommendation followed on to A20 and A22 as well, so it's not like it was plucked out of thin air. A ditch, on the other hand, is simply just that, a scar in the ground, a river, a natural obstacle, distinct from a man-made obstacle like a trench. And like everything else, they come in a variety of sizes. I need you to understand about the shape of a trench. It's more than just that ditch. Once you add in a parapet on the front and the parados on the back as a gap, you can be looking at a gap much wider than the nominal width of the trench. Now, because we're talking gap crossing, we need a quick primer in crossing a gap. The 300G drawing shows a very idealized trench with vertical sides which don't collapse. Yet trenches are not really quite so like this at all. The slit part of the trench is for the troops and may or may not have a firing set within it, depending on whether it's a fire trench, communications trench, etc. When it is excavated, the spoil is dumped both in front and behind the trench, forming a parapet and parados respectively. The parados is usually higher than the parapet, protecting the back of the men's heads when standing up, making sure that they don't get decapitated by explosions or shot in the back of the head. And also it prevents you from being skylined, which would mean being an easy target for enemy forces to figure 12 you. What that meant in tank terms is a rather complicated obstacle where the front of the tank has to climb this step at the front, raising the tank as it moves forwards, up and over the step. The higher and sharper the step, the harder it is to climb, and it could be anything from a single layer of sandbags up to and including a reinforced concrete wall several feet high. If the front contact of the track is below the top edge of the wall, it makes climbing the wall extremely difficult, relying on engine power and traction alone behind the vehicle to lift up the front over the obstacle. This is still a problem for modern main battle tanks. In fact, raising the front or leading edge of a track was one of the key developments in track technology which made tanks a viable concept. As early as 1914, Robert McPhee was suggesting such a raised leading edge for an armoured tracked vehicle. Yet in the early days of tanks, the only notable raised edge track was from the Killen straight tractor, albeit on a very short track run. Track systems, like the Holt, Clayton, Best and Bullock, all had this low track front edge, meaning a relatively low climbing power. This was really the turning point in tank design, where Little Willie, with its very slightly angled front track, proved that track technology with the raised edge was the way forwards. This was taken to its zenith by the Mark I quasi-rhomboidal shaped tank. We will come to quasi-rhomboidals. So making the leading edge very high like this allowed for a high contact point and obstacle crossing ability. A trench from World War I was roughly 2 feet wide at the narrowest and up to 3'6" in the normal fighting width area. a fire trench up to 6'6" across at the top at ground level, and once more with the parapet at the front and parados behind, was more than a simple gap in the ground. Having climbed the step or parapet at the front, the vehicle would then flop down on top of the parapet and tip forwards into the trench. At this point, even if you managed to get up the parapet with a lower leading edge track machine, the prospect was that your tank would then topple into the trench, face planting on the opposite side, becoming stuck. This is the principle on which anti-tank ditches work, and the Germans in particular like to make theirs with vertical sides at both ends revetted in concrete where possible. That would mean no chance of digging the track into the dirt and just muscling your way out. Even a mostly vertical side ditch could be up to 13 feet wide. The angle of attack for the leading edge of the track and the normal length of the track ensured that it would become stuck, face down, against the opposite side and unable to either climb out or to recover itself. On top of this, whilst the vehicle is crossing such an obstacle, it is incredibly vulnerable to enemy fire. The use of a turret, whilst useful for all-round fire, was also limited, but sponsons, that is, mounting the guns in the side, would not have to fire over the nose of the tank and therefore could still fire forwards and to the side, enflading the enemy when the vehicle was going up and down steep slopes over these obstacles. So let's have a quick look at our model here. Yes, it's made out of wood, and that's because I wanted to make sure that we could clearly see, let me point with a pen. Now, in normal terms, we have a flat track length, measuring approximately a third of the length of the vehicle. The subtle feature that people miss is the rear part. This is slightly raised from the ground. It is only really apparent on a hard surface, and the reason for this is extremely clever. Now, whilst when we are turning, it's a function of length to width ratio, the shorter the ground contact length, the easier it is to turn. When it comes to climbing an obstacle, here we have the lip of my bar is exactly halfway to the height of the leading edge of the track. As the track pushes it forwards, you now see why this rear edge is so important, because this now becomes level with the ground. This previously ground contact length is now raised, yet the entire vehicle has gone up relatively little and yet is already halfway up the step. Further, the sponsons are still perfectly able to fire forwards from where they are, whereas a turret on top would already be struggling to get the depression to hit a low target. As the vehicle progresses further up the track and exposes more of itself, a turret on top becomes completely useless, other than maybe firing to one side. The sponsons, however, only have to depress to the same angle as the tank is going up. So here we have the tank going up at 30 degrees, the sponson won't only have to depress its weapon to 30 degrees to the front. To the side, it still doesn't have to depress its weapon at all. It's still able to fire completely horizontally and enfilade the target. Taking a simple trench example, our quasi-rhomboidal tank approaches the step. As the leading edge contacts it, it begins to climb, maintaining contact with the ground, straddles the trench, maintains contact once more, climbs the parados, and then back down to continue on its way. As the tank continues up the step, it gets to the centre of gravity, which on this vehicle is roughly where this little dot is. So as I'm pushing up there, once it reaches its tipping point, it then tips itself forwards as it's climbed the top of the step. And hey presto, now it can continue on its way. Alright, it's only a wooden model and it's very simple, but I hope that really explains it. There are some graphics in the video as well. The same is true on the way down a step. The vehicle will continue to its centre of gravity, whereupon it tips forwards, hopefully more elegantly than that, so that the ground contact on the front meets the ground. You can see how if the track is relatively short, this simply face plants. A turret with a long-barreled gun is going to be digging in for potatoes in the opposite bank. Sponsons, however, are completely acceptable. The vehicle then comes forwards, flops down off the step, and continues on its way. That is trench crossing made simple. Illustrated here is our tank trying to cross a ditch longer than it and becoming well stuck. So with that trench crossing in mind, when in 1939 the Army comes up with what it wants Stern to develop as a special machine, and decides that a 16-foot wide anti-tank ditch has to be crossed, it instantly guarantees that the vehicle had to have certain features. Specifically, a high front track edge to meet that opposite face, and a long body to accommodate the width of the trench. That's not the end of that impact decision either. The Army also wanted a very low ground pressure and heavy unditching gear and invulnerability and a gun which could breach heavy fortifications. Quite a shopping list. The trench crossing requirement guaranteed a long vehicle, and the demand for immunity meant heavy armour. Those, combined, ensured a heavy vehicle, meaning a big and powerful engine would be needed, but perhaps the biggest design limiter was the demand for heavy unditching gear. Now, it's not exactly clear what the Army had in mind, as they did not elaborate on the term, but we know almost exactly what they meant in terms of freeing itself from a ditch or shell crater. And this would be a heavy timber beam slung across the top of the vehicle, which could be picked up by the passage of the tracks, attached by chains, and pulled over the top of the machine, pulled then under the tracks to gain traction, pulled all the way under, up the back, and then back on top. So what this meant was that the Army's choice for a design could not have a turret. A turret obviously would get in the way of unditching gear travelling over the back of the vehicle. Now, the turrets that stick up on top of the quasi-rhomboidal tanks, they are not rotatable turrets, and there would be metal framework for the timber beam to move over. That is obviously not possible with a rotating turret in that sense. So what the Army meant was that the Army's choice for a design could not have a turret. A turret obviously would get in the way. More than that too, it also meant an all-round track design. This is an all-round track design. Rather like the World War I era Mark VIII, in fact. A long, high front end, all-round track with no turret and heavy unditching gear. This design move was inevitable given the demand for unditching gear. Speed was not relevant, so at least suspension wasn't a concern, but firepower was still an issue, and the demand for this heavy breaching gun for a vehicle of this shape leaves only two options for mounting. The first was in the front, facing forwards, and the second is somewhere in the side. This is where the Army's choice comes in. Now, coming to that first meeting, the Army brought with them a design called the Citadel. This is a giant Mark VIII style tank with heavy armour and large, presumably cast sponsons, each containing 2-pounder guns and machine guns and a large gun in the front. It must be no small irony that it was Stern back in World War I who led the work on the Mark VIII, for he was for sure very familiar with the design of this style and with the issues associated with it. Things like where to put doors for the crew, how to protect from enemy troops all around in the absence of a turret, and more importantly, how to drive and steer such a machine. We also see a clear divergence of thought too. Stern and the team he was putting together wanted a turreted tank, longer, better armoured, and better crossing obstacles than currently existed, but the Army wanted something different. No matter how hard they tried to demand a turret, the Army was insistent on what they wanted, and here then we have why perhaps so many will casually claim that the TOG tanks are World War I throwbacks. Yes, for sure the Army were thinking more heavily in World War I terms, but the old gang were not. As the team would bring their designs forward through development then, there were two distinct lines of thought. The Army preferred plan with an all-round track, turretless, and the TOG choice, with a turret. The Army preferred scheme would end up taking shape in what became TOG-1. We shall come to that vehicle. If we conclude here, then, with a segue to this TOG choice of design, though, Stern, as we discussed in the last episode, could be more than a little bull-headed in the sense that he knew exactly what needed to be done, and he was not well known for asking before he decided on a course of action. Thus, whilst the team would work on the Army design, his team would work on their own ideas, drawing knowledge from the development of the Army's vehicle to produce another vehicle better in every way, yet still able to achieve the core of what the Army wanted: a heavily protected vehicle capable of crossing poor ground and obstacles, and smashing enemy defences. This would morph a little later on to take a stronger element of defeating enemy armour too, but as before, we have to come back to that as there's simply far too much ground to cover on that topic. So what I need you to do now is to consider the Army's needs as laid out in RBM 17. And I'd like you to draw from that the inspiration for a turreted design to meet it. Sure, there would not be the opportunity to use heavy unditching gear, but if the vehicle had a low ground pressure and good traction characteristics, this might be obviated as a problem. The other obstacle crossing feature, however, was more complex. If there was no need for the unditching gear, then there was no need for the all-round track, but there was still a need to have a high leading front edge. When we think back to 300G, we see a conventional style of track with a uniform profile on the track run, parallel to the bottom one. But what if you could use a low track system with a raised front wheel? If you could make that work, then you'd solve the leading edge problem, have a much greater internal volume, and with it a much greater freedom of design. That brings us to Talk 2. That is the end of the design philosophy that comes from the Army. Please check out the links below. If you like this video, or any of the others like it on this series, then please follow FWD Publishing on Facebook or on WordPress. There is a Patreon too, if you be so kind as to help support this channel, my work, my research, and my books. And if, as always, you have any questions, please put them in the comments below to this video, and I will try and address them at a relevant point in the series as we go forwards. Thank you very much, and good night.